Let's take a look at simplifying for the radical in quotient problems or division problems with the radical. Uh, Let me say this first. Oh, well, I wrote this wrong, first of all. The example 32.1 says radical 3 over 7 and makes it look like this. Well, you can actually write this two different ways. You can write this like so with a very long square root sign, or you could actually write it, it's the same thing as square root of 3 over square root of 7. Either one of these work, they are the same exact thing. Now, I personally like this style, but once you see this, notice we have a radical in the denominator. In a past lesson, we said that a problem is not simplified if it has a square root sign or radical in the denominator. So therefore, we have to get rid of that. Now, how we did that in the past is how we'll do it here. So what we want to do is multiply by square root of 7 over square root of 7. I want to multiply it by itself in the form of 1. Because then what happens is we get square root of 3 times square root of 7. That is square root of 21. 7 times 3, 21. Square root sign stays there. And then on the bottom, we get square root of 7 times square root of 7. And we've talked about if you have two of the same square roots, then that comes out just to be one of those numbers. If you remember, square root of 7 times square root of 7, square root of 49 equals 7. But this right here would be your answer. Square root of 21 over 7, and that's all you have to do when solving for these quotient radical problems. So let's look at a couple more examples. Example 32.2 gives us two of them. Square root of 2 over 5 plus radical 5 over 2. So, so what we're going to do is the same thing that we did on the last one. Multiply by the square root in the denominator. So this one has the square root of 5 in the denominator. So we multiply by square root of 5 over square root of 5. And we get square root of 2 times square root of 5, square root of 10. Square root of 5 times square root of 5, radical 25, which would be 5. Then we do the same thing here. Now what's in the denominator? It's a square root of 2, or radical 2. So multiply by radical 2 over radical 2. Square root of 5 times square root of 2, radical 10 over 2. Now from this point, you don't want to leave it as that. That is actually not simplified. We now have whole numbers in the denominator. And if you remember in these fractions, we can simplify by finding the least common denominator. Least common multiple for the denominator. Well, 10, 5 and 2 both go to 10, into 10. So what we can do is multiply by 10 over 10 here. Multiply by 10 over 10 here. The 5 crosses out, becomes a 1. This 10 becomes a 2. So that would equal 2 radical 10. 2 radical 10 over 10, because 10 times 1 would be 10. Notice here, this is 2 over 10. That could be reduced to be 1 over 5. But that would just be what we have here. So we basically just doubled it. And some of you can probably do this mentally and be able to see it, but this is technically how you do it mathematically. So we did the same thing here. 2 crosses out. This 10 becomes a 5. 2 goes into 10 5 times. And becomes 5 radical 10 over 10. Now we have the same denominator. And these are actually like terms because of the radical 10, so we can add what's on top. The 2 radical 10 plus, let's look at this part real quick. That's That's the same. It's the same type of. It's like terms. It's just like saying 2x plus 5x. Well, if you have 2x plus 5x, you can say 7x because they have a like term of x. This is 2 radical 10 plus 5 radical 10. They have the same term, so therefore you can say 7 radical 10. So we would get, this would equal 7 radical 10 over 10 for your final answer. 7 radical 10 over 10. Let's look at one more example. It tries to throw a little curveball. In this one, it adds a whole number in front. Well, we start the same way. Got to get rid of the radical in the denominator. So in the first one, we're going to multiply by radical 7 over radical 7. Also throws a negative at us. Square root of 2 times square root of 7, square root of 14, over square root of 7 times square root of 7, 7. Now, if I was writing the 2, if you just write it like that, I mean, you could, but remember, 2 is over 1. 2 is over 1. So it's really on the top part of the fraction. It's in the numerator. Okay? And then over here you have radical 2 in the denominator, multiply by radical 2 over radical 2. And you get negative 5 radical 14 over 2. Square root of 2 times square root of 7, square root of 14, square root of 2 times square root of 2 is 2. We're like terms in the numerator, however, in the denominator they are not the same, so we got to multiply to get the least common denominator. Least common denominator, or multiple, between 7 and 2 is going to be 14. So we multiply 14 over 14. On both sides, 7 and 14 can reduce to 1 and 2. Now we do actually have this 2 and this 2 need to be multiplied. So 2 times 2 would be 4, radical 14 on the top, over 14 in the denominator. Notice, once again, 2 over 7 is the same thing as 4 over 14. We just doubled it, essentially. Do it over here. 2 goes into 14 7 times. Got to multiply the 7 times the negative 5. That would give you negative 35. Radical 14 over 14. 4 minus 35 would be negative 31. So the answer would be negative 31 radical 14 over 14. There you go. Thumbs up. Easy peasy, lemon squeezy. Let's go to one more concept in lesson 32. Talking about congruent triangles, you're going to like this. This is easy stuff right here. This is our sign for congruent. And notice these have the tick marks. And it actually has sides that are congruent. So these have angle, you could say angle. Remember, if 2 angles are congruent to each other, then the third is automatically congruent. But point being is these are, they have angle, congruency. And there's a acronym CPCTC. I'm not going to write out each word, but it means corresponding parts of congruent triangles are congruent. We know that these triangles are congruent to each other. So therefore their parts, meaning their sides and angles, are also congruent. You can see how side 6 over here is congruent with side 6. So therefore these sides are equal, or congruent, these sides are congruent. And we need to solve for x and p. So if we know that these two sides are congruent, we can just put them equal to each other. 6x plus 2 equals 12x minus 4. Subtract the 6x. Trying to isolate to get x by itself. 6x minus 4 equals 2. Add 4. Whoa, what do you know about that? 6 equals 6x. They made it fun and easy for us. X equals 1. X equals 1. It didn't even want us to know the sides. It just wants us to find x and p. So we got x. Now we need to solve for p. So therefore, 4x plus 1 equals p. We know that x equals 1. So we could say 4 times 1, or just eliminate the x. 4 plus 1 equals p. Think. Therefore, p equals, let me plug that into my calculator, p would equal 5. And there would be your two answers. And that's how you do corresponding, or congruent triangles, sorry. But that is the end of lesson 32.